XAML. We will continue our pattern analysis for GATE DA 2026. We will start with the first subject, probability and statistics. To begin with, this is the one subject we will get a lot of questions. Okay. Up to 18 marks, definitely out of 100 marks. So this is the highest weighted subject in GATE DA till now. Overall pattern, it will be very easy to moderate, okay? Not so tough, difficult. And one good thing for you is some formulas you can directly use. Okay? So some reasoning will be there, some direct formulas you can use and simplify and then get the answers. We'll see those questions, some previous GATE PYQs here. So please watch till the end. Okay? So to just begin with, so there will be more number of 1 mark MCQs, okay, or NATs. So 1 mark there can be 4 to 5 questions, very simple formula based questions. Little bit of trick will be there, but still you can still manage them. And then 2 marks MCQs or multiple select questions, you can expect 3 to 4. And then NIT definitely 1 or 2 mark, you can expect 3, 4. So total around 18 marks directly. And then again in machine learning concepts, they may again embed the probability statistics concepts. Okay. So let's see all the topics. See, whatever topics you are seeing on the screen, it is sufficient. So you may not believe it. To understand each of these properties or the procedures in depth with all the formulas associated with them and understand those formulas, and then for exam purpose you can just remember those formulas for quickly solving in the exam. So most likely these are the topics, and definitely you'll expect question on these topics only. So I'm not saying that you should not study other concepts, but most of the concepts are covered here and they are the frequently asked questions topics. So in probability theory, the basic probability theory, axioms and rules, conditional probability, total probability and Bayes theorem. We'll see each of these in depth. Random variables, EMF and PDF, density function evaluation, how to form a CDF, the conditional distributions, this is very important, and joint distributions. These two are very important. And here, this is mostly logical based question. There are no formulas here. Just you have to understand and then solve logically probability questions. Then expectation, variance and covariance. There will be too many questions on this. This is one heavyweight topic. Expectation, variance and covariance. There, normal expectation of a single random variable, expectation of variance, covariance for joint distributions, they will definitely ask. And then expectation and variance for different probability distributions like discrete distributions and continuous distributions. And one important concept here is linear combinations. We'll come to that later. And then probability distributions, in the syllabus they have introduced only few distributions, some discrete and some continuous. So one question definitely on either these three or and this. Okay, definitely will find out. So 4 marks only from probability distributions. Then central limit theorem and confidence intervals. You can expect 1 or 2 marks. So compared to these topics, these are not heavily asked. So out of these 4 major topics, you can expect around 15 marks directly from here only. So here you should understand only the concept. 1 or 2 mark question they may ask here. So now let us understand what are the things they ask in the basic probability theory. Here the questions will be a little bit tricky, but there are no formula based questions here. Only thing is you have to understand, apply your logical reasoning and aptitude and solve those problems. So definitely a question will be on conditional probability and Bayes theorem, which includes law of total probability. All these three including, they'll ask a question. Definitely they'll ask a question. And make sure you understood the basic laws of set theory, so which are applied again to your probability, like De Morgan's law, all those laws. Just refresh them once that you learned in set theory. Same thing will apply for probability theory also. So this will be very helpful. Okay, each question they give on this concept will definitely be using these formulas. Okay, so I told you in the beginning, formulas you can use here in this subject because these are all formula based. They will not ask a direct formula based question, but when you solve the problem, definitely will require some of these. For example, De Morgan's laws and all. So we'll solve some problems, we'll understand. What is exactly tested in GATE in this part or in these topics? Identify correct conditioning events. Okay, that is the conditional distribution probability. So here you'll mostly test your logical reasoning. It means how you are going to arrange your sample space as well as your events. That is how you calculate your discrete probability. Next, one heavy topic is expectation, variance and covariance. You have to understand the expectation for the density function as well as probability mass function. How you derive it is important. Don't just mug up the formulas here. How you calculate them, you should understand that. How you got that formula, you have to understand that. So that in the question it will be easy. Expectation, variance and then covariance. So similarly on joint expectation also. So most likely in the question it will involve linear transformations. So in my textbook and as well as video lectures I explained there are different linear combinations for each of the expectation and variance, You just go through them once in the revise. So conditional expectation, definitely one question on it. So from conditional expectation, you will get the covariance. And then there are various tricks I have given in my book also. I solved many problems on this. Please go through those video lectures. I have pinned the lecture videos in my comment box. So to understand joint PMF, joint PDF and conditional PDF, then from that you can understand your conditional expectation as well as the variance and covariance concept. Then when it comes to random variables and some discrete distribution, some continuous distribution. So as per the syllabus, there are the discrete distributions are Bernoulli, binomial, Poisson. Okay. And then you have some continuous distribution, exponential. Uniform can be both discrete and continuous. Normal and standard normal is one question definitely on this. Okay. And then they may also ask the conversion between CDF, that is cumulative distributive function, and probability distribution function. I have already given many derived simple formulas. Okay, end results I have given around for discrete and continuous together. I have given some 20 plus derivations, just the end result. So, for example, when you give P of x greater than 5 for discrete, how should I write this? How should I simplify this? So, just go through my video lectures once again. Then, based on the approximations of central limit theorem and confidence interval, you may expect one question. So, that will be very simple. That is, again, it is nothing but standard normal distribution. So, some properties are to understand here: central limit theorem properties, confidence interval properties, and how approximation is done to normal distribution. That is what you have to understand here. They are not very complex because in your syllabus they are not introduced hypothesis testing. Only the basic requirements are given here, but hypothesis testing is not given. So let us see some examples and how can we solve them. Okay, what is that they are testing in these examples for questions. A and B are considering applying for a job. Probability that A applies for a job is P of A is equal to 1 by 4. Probability that B applies is not given, so let us find it later. Then probability of A given B has applied is 1 by 2. Probability applying B that A will apply is 1 by 3. Now what is the probability that A does not apply given B does not apply? See, they are asking probability of A does not apply means let us say complement. Given B complement. This is what I have to find. So for this I need the conditional probability definition, that is probability of A dash intersection B dash divided by P of B dash. You find all these terms. So find this first, find P of B. So P of B is equal to, how will you find? So let us find from this. So P of A given B can be written as P of A intersection B divided by P of B. Okay. So now this is P of A given B. This is given it as 1 by 2. Now, so I need to find P of A intersection B, so that I will get P of B. Now from the other one, P of A intersection B or B intersection A, that is commutative, divided by P of A is equal to P of B given A. I can write like this. So this is given as 1 by 3. See, from this I can find out definitely P of A intersection B. P of A intersection B is equal to 1 by 3 into P of A is 1 by 4, that is 1 by 12. Now you substitute here and then find P of B. So P of B is equal to 1 by 2. P of A 1 by 12 divided by 1 by 2. So that is 1 by 6. So P of B complement is 1 minus 1 by 6, that is 5 by 6. Now you apply De Morgan's law. So we want to find, say if we give you A union B and then take the complement of this, you will get A prime intersection B prime, that is De Morgan's law. So if I apply probability, I will get this. Now, how will I get this? This is nothing but 1 minus P of A union B. So you find P of A union B, 1 minus P of A union B. So I already know P of A, P of B and P of A intersection B. So this is nothing but P of A is given as 1 by 4 plus P of B is 1 by 6 minus 1 by 12. So then substitute and then get the final intersection value and then substitute here. P dash you already got 5 by 6. So the final answer we get it as 4 by 5. If you observe this question, getting the solution is fine, but see how many things they have tested here. First your conditional probability concepts, then how will you simplify? Okay, that is nothing but your aptitude and logical reasoning. And then how will you apply the basic set theory laws? Most of the questions will the combination of this in the exam. Even if you are stuck somewhere, just think in this angle, some set theory combinations. Now, one more type of question is based on some counting. Suppose the pair six-sided die is rolled once. If the value of the die is 1, 2 or 3, the die is rolled the second time. If the value is 4, 5, 6, it is not rolled again. So what they are saying, so the toss 1, 2, 3, 4, 5, 6. So I will get any one of this. If I get 1, 2 or 3, I will go for the second toss. So again second toss, the outcomes will be 1, 2, 3, 4, 5, 6. So this means if 1, then it can be 1, 1, 1, 1, 2, 1, 3, 1, 4 like that. So total 36 combinations. So what they are saying, what is the sum of total of values that turn up is at least 6. That means what? 6 or greater than or equal to 6. This is what is I have to find how many such outcomes are possible. So total, if it is 4, 5, 6, again I am not going for the second toss. So here what is the probability? I will get the probability as 1 by 6. See, 1, 2, 3, I will repeat 4, 5, 6. Out of these 3, which one is at least 6? Only 1. So 1 by 6 out of these 6 plus. Then I have this combinations. If it is 1, then it can be 1, 2, 3, 4, 5, 6. Out of this sum, which one will form 6 or more than 6? So 1 plus 5 and 1 plus 6. So there will be 2 combinations out of 36 plus. Similarly for 2. 2 plus 4, 2 plus 5, 2 plus 6, 3. Plus 3, 3 plus 4, 3 plus 5, 3 plus 6 and 3 plus 3. So this will be 4 by 36. So that is the answer. So we'll get it as 5 by 12. Next. Similarly, again based on the counting principle, a random experiment consists of throwing 100 pair dice. Each die has 6 faces numbered 1 to 6. Let A represent a set of all outcomes where at least one of the dice shows as 1. If you check out my combinatorics video lectures, I have solved many problems similar to this and more complex. See, it is difficult to find at least one. At least one means you have to go for 1 or 2 or 3 or 4 or 5 or 6. Okay, then the solution becomes lengthy. It will take time. So what you can do in such cases, I have solved many problems like this. At least one means you find out none and then subtract 1 minus none, the probability of getting none as 1. So that is nothing but 1 minus probability of not getting 1 is what? 5 by 6, right? Out of 1, 2, 3, 4, 5, 6 cases. So not getting 1 is 5. Total 5 by 6 out of 6. So this is done 100 times. So this is the answer. Straightforward. Now, based on the expectation and variance, be very careful here. The questions may look big or little bit tricky, but they are very simple if you understood the properties and the linear combinations of expectation and variance. Now they are saying consider a finite sequence of random values x equal to x1, x2, xn, and mu x be the mean and sigma x is the standard deviation of this random variable x. Let another finite sequence y of equal length be derived from this as yi equal to axi plus b, where a and b are positive constant, and let mu and sigma be their mean and standard. What they are saying, there is random variable x which takes some values x1, x2 and xn. There is another random variable y which takes y1, y2 of same length, yn values are there, and they are saying each y value is related to x. Let us say yi equal to a into xi plus b. A and b are some constant. Now they are saying which one of this is true or incorrect. Which one of this is incorrect. The index position of mode of x is in x is same as the index position of mode of y in y. See, what is that you are doing here? You are just scaling those. Okay, so you are multiplying by a and then adding b. So for every variable you are doing the same thing. So y is just a scaled version of x. So that means what? This will remain same. Even the index position of median will also remain same. You can take some numbers and then test it. You take some a equal to b equal to from constant values and then take this, you will get the same answer. That is the property. Okay, linear combinations. Then they are saying which one of these two. So they have to calculate this. Now, how will you calculate this? See, let us say expectation of x and expectation of y, that is mu x and mu y. I'm simply writing e of x and e of y. So how will you find e of y? E of y is nothing but, what is the relation? A x plus b. Right? This is nothing but using the linear combinations. You can write it as a into e of x plus e of B. This is A of E of x is again, they are given it as mu x plus expectation of a constant is always the same number B. So this is nothing but mu y. So this is true. Now similarly you check for variance. Variance of x and variance of y. What is variance of y? That is nothing but ax plus b. Now here directly the linear will not apply. So when we take the variance, I have to square this when I bring this outside. So a square variance of x plus variance of b. The variance of a constant is always 0. This property remember. Okay, definitely in this exam they will ask a question based on this. Suppose x and y are random variables. The conditional expectation of x and y given denoted by e x given y, then expectation of this equals what? So this is, you can try it, you can just use the definition and then find out in the exam. So it's from the concept of law of total expectation. Just like your law of total probability, there is a law of total expectation for conditional expectation. So this is directly nothing but E of x. You can just verify. Next, a bag contains 5 white balls, 10 black balls. In a random experiment, n balls are drawn from the bag at one time with replacement. This is important, with replacement. Let Sn denote the total number of black balls drawn in the experiment. The expectation of S100 denoted by E of S100 is, this is a random variable for 100, n equal to 100, and then they are asking the expected value of such experiments, n balls. Okay. So first find probability of white is 5 by 15. So 1 by 3. Probability of black balls is 10 by 15, that is 2 by 3. So total probability is 1. Now, what is the expectation of the black balls? 100 black balls. How will you find what is the probability? I have already found. So expectation of the black balls is x into f of x, right? So n, we don't know n because again n balls are drawn. N into 2 by 3. That means what? When I draw n balls, 2/3 of those balls will be black. That is the average value. That's what is the meaning of expectation. So this is 2n by 3. Now if there are 100 balls, n is 100 they are giving. So they are just confusing you here. There is nothing in this problem. 200 by 3 is around 66.6. The answer. No, 2 pair coins are tossed independently. Let x be a random variable that takes a value of 1 if both tosses are heads and 0 otherwise. Let y be a random variable that takes value of 1 if at least one of the tosses is heads and 0 otherwise. The value of covariance of x and y. This is where I told you, you may use your formulas directly, apply. Covariance of x comma y can be given as expectation of x y minus e of x into expectation of y. Now you have to find each of them independently and then plug in this. How will you find e of x? For that you have to first find p of x. So what is that they are saying here? X equal to 1 means what? If both tosses are heads. In a toss, I have sample space, head, tail, tail, head and tail, tail. 4 outcomes. When this x equal to 1, only when both are heads. So what is the probability? I'll get it as 1 by 4, both the heads, right? So 1 by 4. Similarly, let us write as probability of x equal to 1 is 1 by 4. What will probability of x equal to 0? 1 minus 1 by 4. Okay? That is 3 by 4. Similarly, when is y equal to 1? If at least one of the tosses is heads, that means what? This is taken, this is considered, this is also considered. At least one head, except this. Both are tails here. So this is probability of y is equal to 1 is 3 by 4. So probability of y equal to 0 will be 1 by 4. Now you find the expectation of x. E of x is equal to x f of x, right? Summation. So 0 into 3 by 4 plus 1 into 1 by 4. This is 1 by 4. E of y similarly will be equal to 0 into 1 by 4 plus 1 into 3 by 4. This is 3 by 4. You find E of xy. Xy means what? Xy is equal to 1. When will both x into y will be equal to 1? This is possible only when x equal to 1 and y is equal to 1. Now you find out how it is possible. So x equal to 1, y equal to 1 means what? X should be 1 when both are heads. Okay. and y is equal to 1 when at least 1 is 1. So that means if you take the intersection of this, only one possibility out of 4, which will be both, okay, x equal to 1 and y equal to 1. That is only when it is head-head. So the probability of xy is equal to 1 is 1 by 4. To find out the expectation now, E of xy is equal to 0 into 3 by 4 plus 1 into 1 by 4. So this is again 1 by 4. So this is nothing but 1 by 4 minus 1 by 4 into 3 by 4. So you will get the final answer as 1 by 16. That's it. You observe here, there is nothing here, just you have to think and then understand these formulas. Similarly, based on the binomial distribution they have asked here, consider a point toss experiment with probability of head showing up is P. That is probability of success. In the ith coin toss, let xi equal to 1 if head appears, 0 if tail appears. That is a random variable. And then they are given the estimate. P hat means P estimate for the success probability is sum of all divided by n. So they are taking xi, summation of xi divided by n, average of how many heads I am getting. So that is straightforward approximation for binomial distribution, where n is total number of independent point tosses. Which of the following statement is by R correct? Okay. So now they are asking expectation of this P hat. Okay, so you already know it follows binomial distribution. So you can write expectation of P hat is equal to expectation of, what is this P hat? 1 by n summation of I equal to 1 to n xi. Okay. So this is nothing but E 1 by n will take out summation of I equal to 1 to n E of xi. Right? What is this E of xi? Expectation of this random variable xi. This random variable xi follows what? Binomial distribution. We already know what is that. 1 by n into this entire thing becomes np. Okay. So this is p into adding that p n times, it is np. So this is the answer. Then so this is not correct. As n increases, variance of p hat increases. You already know that the variance depends on the n, that is sample size. So definitely applying the law of large numbers. Okay. It says that as sample size approaches infinity, the error decreases. That is variance decreases. This is also true. Okay. That is how they test your properties. Next, the question based on CDF. This is straightforward question. Let x be a continuous random variable whose cumulative distribution function is given like this. If the median of x is 3, what is the value of t? Okay. The CDF, if I write p of x equal to x, okay, random variable x, takes some value small x. This we represent usually as PDF or PMF, density function or mass function. When I write CDF, this is the format, x is less than or equal to x. Please go through my videos. I have given detailed understanding like how to solve these problems and the logic behind them. So what is the thing? They are given this and they are saying median is of x is 3. That means p of x less than or equal to 3, the CDF that they are given here is equal to, when they say mention median, you should know the concept that when I mention CDF find median, so this value will be exactly 0.5, 50%. That is a rule. So x less than or equal to 3, see, this is what they are testing here. This concept you should have known. That's it. Then you substitute here. So x less than or equal to 3 means it belongs to this case. So x minus t by 4 minus t is equal to 0.5. The f of x means what? This is what they are written. Okay. Or we can write it as capital F. Some books mention it like this. So you find out t. So t will be equal to 2. So straightforward question. Only thing they are testing here is whether you know this concept or not. Median and CDF, mean and CDF. Next, let x equal to a z plus b, where z is the standard normal variable and a and b are unknown constant. It is given that e of x equal to 1 and this is equal to minus 2 and variance equal to 4. See, this is expectation, this is variance, and this is some logic they are given here. You will see how they will help us. So what they are saying, x is equal to a z plus b, and where z is the normal standard normal variable. So that means what? Z will have mu equal to 0 and then variance is equal to 1. You already know. You have to find this concept, find a and b. How will you find? The expectation of z is equal to what? What I written 0. So standard normal variable. Variance of z is equal to 1. This concept they are testing here. Now substitute here. E of x will be equal to what? A into E of z plus E of b. This E of x they already given it as equal to 1. So now just simplify it. A into E of z is what? 0 plus E of b is b constant equal to 1. So that implies b is equal to 1. You found out b equal to 1. Straightforward. Next, how will you find a? To find a, use the definition of variance. They already given variance of this is equal to 4. Now already know how to find variance of a z plus b. So this will be a square. When it comes a constant comes out becomes square in the variance. Variance of z plus variance of b. So just I told you in the previous problem this is 0. Variance of constant is 0. They are again testing this here. This is nothing but a square. Variance of z is 1. And this value they are given it as 4. So a is equal to plus or minus. A equal to plus or minus 2. So now check the options. They are given a equal to minus 2 and b equal to 1. So this is correct. Now sometimes you observe here carefully. Suppose say that if they are given this as plus 1, what would have done? B equal to 1, A equal to 2 also, right? So for that they are given this. The option they have not given that, but based on this again you have to find actually the sign of A, whether it's minus 2 or plus. Given that probability of P of x greater than or equal to 2 is 0.25. For an exponentially distributed random variable x with expected value 1 by lambda, what is the value of lambda? Given the standard exponential distribution, but they are given the, they are not given the PDF or CDF here. Greater than 2 equal to means what? You have to consider 1 minus P of x less than 2 and apply the CDF. So this is nothing but a exponential survival function e power minus lambda x. This means e power minus lambda x. This is the unit as 0.25. That's why I told you sometimes the formulas may help directly. So e power minus lambda into x is 2, right? Greater than or equal to 2. Equal to 0.25. Now apply log and then find. So you get A as the answer. Next. Let x be a random variable exponentially distributed with parameter lambda greater than 0. The PDF of x is given. They are given the exponential distribution. Most of the exams they will mention it. You will not remember this, but sometimes it's better if you remember the formulas. That question. If phi of ex equal to variance of x, see, you already know phi into expectation of a exponential random variable is 1 by lambda. This is equal to variance is 1 by lambda square. That's why I told you. Sometimes it's better to remember this formula. Expectation and variance of each distribution. So you calculate the lambda value. Lambda will get it as 0.2. That's simple. Now, based on central limit theorem, the question looks very big, very simple. A random variable x. I solved many questions. Please check out my video lectures on normal distribution and standard normal distribution. I solved many problems similar to this. A random variable x is said to be distributed as Bernoulli. So theta is the parameter, that is success probability, denoted by Bernoulli of theta if p of x1 equal to theta. That means success probability x equal to 1 is success. That is success probability is theta. Failure probability is 1 minus theta. You already know. And then they are given random variable y equal to summation of y equal to 1 to 300 xi. So they are independent and identically distributed. IIT condition. This has to satisfy for any distribution. And probability success probability is 0.25. They are asking the approximation using central limit theorem to normal distribution. They are asking p of c less than or equal to y less than or equal to 90. So you convert this into this phi they are given means what? Standard normal approximation, that is the g value. The g tables are not given, instead they are given direct values here. How will you find this? So the concept is very simple. So find out your mu and sigma, that is to find out the standard deviation as well as the mean. So for Bernoulli you already know the variable y, mu y, right? For this we are calculating. So mu y is equal to np, that is theta they are given here. So that is 300, n is 300 and then 0.25 is the probability. This will be 75. Similarly, variance is nothing but n theta or np into 1 minus theta. Instead of p, they are using theta here. So when you practice the problem, you will be dealing probability as p, np, and p minus like that. So when students see the theta, alpha, beta, they get, okay, this problem is very tough. Something is tough here. 56.25. So you take the square root of this and the deviation will get it as 7.5. So now we'll convert this. So convert it to standard normal. First find the standard normal variable, the z variable. How will you get this? X minus mu by sigma. So you have found out this both. Okay. So z equal to, I am saying is y minus mu y by sigma y. What is that they are asking? They are asking this. So p of 60 less than or equal to y less than or equal to 90. So convert this to standard z. So z1 is equal to this y1, that is 60, minus, so got mu as 75 divided by sigma y. Sigma y is 7.5. So this will get it as minus 2. Similarly, z2 is equal to 90 minus 75 divided by 7.5. This is plus 2. Now how will you write this? This is nothing but p of minus 2 less than or equal to z less than or equal to plus 2. Okay. So how will you find this value? Phi of 2 minus phi of minus 2. In the exam, they may give value for this z values. Okay. There is z table, right? You just check my video lectures. I explained how you get this. So this is the answer. You see, it's a very simple question actually. There's nothing in this. Okay. So next we'll see calculus concepts. Hope you have enjoyed this. Please prepare well, understand the properties, and solve more problems. I also given my video lectures on many practice problems. Thank you for watching. Please like